A discrete source emits one of six symbols when even the m-second. M-second, the simple probability are 1 by 2 and 1 by 4 and 1 by 8 and 3. This is our probability. And what we solved in this source entropy, it's very simple. It's very simple. We know about what's the formula of entropy and how many term is propagation we have, 6, and we will put it our all term in this formula and we will get easily in this answer. So very easy, not a more tricky in here. What is tricky in this question is the m centimeter, m second. What is the m second in here? Information rate. How we can solve in information rate in here. Information rate is rs is equal to rh. R is equal to 1 m second point per m message per second. 1 message per second is equal to 10 to power 3 message per second. 10 to power 3 message per second. We have that, and we have already solved in this with the help of source entropy formula, and we will get beat per second. You can see in here how we are solving that question with the help of this. Information rate is R is equal to QH. H is here entropy, energy, and R is here rate of which message per generated. So how we can solve in this formula with the help of that. Okay, now you got it. What is that? And R is here, R and message and second, multiply H in information beat, and message is equal to information beat and per second. Messages cancel out in here. What will we get? Information beat and second. So with the help of that we are solving in that. Okay, now you got it, I think. Next, our next question we have, it's really very easy. In our previous question we have one tricky thing. What is information rate is there. So even has 6 possible outcoming with a probability. We have a probability is here. They find the entropy of this symbol. Also find the rate of information if there are 16 outcome per second. Here also same as question like that. Our last question, it's same as like that. Here also given is 16 per second. Here given is 1 per second. 1 per second is 10 to power 3. Okay, and here already given is like that. Information rate is here. What is our in here? We have entropy HSH. We taking the formula of what entropy formula we followed in here. After that we getting our answer 3 by 16 beat message, and after that we solved in the same like that, same like our last solvation. We have a formula 16 outcome per second, they are already given and we just putting in here. We already solved entropy source in here, and after that we applied in here, so we will get in that answer. That is our answer. Very easy, so easy. Everybody know about what's the formula of entropy source. Is the formula of pk log 1 by pk, same as like the summation n by k is equal to 1. So this source generation information, this probability P1 is equal to 0.1, P2 is equal to 0.2, P3 is equal to 0.3 and P4 is like that. Find the entropy of the system. What for What percentage of maximum possible information is being generated by this source? So here again, first of all, we will apply the formula of entropy, and we just putting our this value in this formula, and after that we will get entropy source. Result, it's very easy question. Okay, now maximum possible information. Here is the maximum possible information is h maximum and log m and log 4 and 2-bit message we have. Okay, hence the percentage of maximum h maximum generation by the source h by, how we can solve in h maximum, we have one formula, h by h maximum dot 100. So we just putting our that value in here, that formula, and we will get easily our answer. When we will solve maximum possible information, h maximum is equal to log m. M is here, we have four probability bits we can say. So when we solved in these, so log 2 and log 2, after that our bit is becoming 2 bits message. So don't be confused in here like where it came in 2 bits. We just putting here our h maximum is that, and we just putting in here in the formula, and we will get easy what's the answer in that. Again, after that, what's in our question? Our question is that join the conditional entropy example, the discrete source transmission message x1 x2 x3 with the probability that, and the source of connection of the channel given, calculate all the entropy. We just draw in that, and like our x1, and we just making this metric, and we taking in that in here. What is our px? Px we have given already. Our px is that px already given. What's the formula is that, and what type of formula we are applying in here? You can just see in this question we are applying or formulas. You can see very briefly and clearly the joint probability matrix. First of all, we are applying in here joint probability matrix pxy can be obtained by multiplying the row x yx in that px ps ps. That is already given we have, but we have given already 0.3 is a px. We have 0.3, 0.4 and 0.3. We just these terms we added in here, multiply in here, so we will getting easily pxy in different form. We will getting in the same thing in here. And how we can solve in a py1? We just adding our row column. We just adding our columns, and here, and p3 we will get in like that. Okay, so the condition in the same as in here also, we just adding in that we will get, so the